Okay, we're rolling. Luis Bezenberger, welcome.
Thanks for having me. I'm very excited. Nice to meet you.
Excellent. Luis Bezenberger is with BrainBot, which is a development house behind the topic for today, which is Shutter Network. Before we get into the weeds of Shutter Network, tell us a little bit about you and how you got into crypto.
Yeah, so originally I'm a finance background, and I did some banking internships, I would say originally. In parallel, I was always more sort of technically interested. And at some point that culminated me sort of starting in the crypto space. So actually, via my bachelor thesis 2015, I wrote about blockchain kind of as a settlement and trading and clearing system. And that's how I then started in 2016 to work at this company called BrainBot, which I'm still with. And BrainBot is originally a core developer house behind, also having started kind of this journey on Ethereum. So building one of the Python, one of the core clients back then, the Python client, in 2014 of Ethereum, and then having kind of just been doing a bunch of other protocol level L2 infrastructure level projects, and then Shutter is the current focus.
Got it. Let's pivot to Shutter Network. Tell us about Shutter Network, what it is, and who the initial target audience is for Shutter Network.
Yeah, so Shutter Network is an encryption as a service mechanism, I would say. So it's a network that provides encryption and decryption in a decentralized fashion, and it's especially sort of threshold encryption, which has this nice property of it being sort of unstoppable. So it enforces the reveal. So we apply it usually to kind of commit reveal use case. There's also some privacy potential, but primarily it is not really a privacy project. It's more so in these instances where you need to have something encrypted and then forcibly sort of revealed. So kind of the primary use case that we've been seeing in the target audience is chains or tools or sequencers that want to offer a level of MEV or front-running protection, and then we would apply it in this form of an encrypted mempool. So the basic idea there is we encrypt transactions and have the sequencer, the rock producer, commit to the ordering and to the inclusion of the transactions while they're still encrypted. So they don't know what's inside the transactions, while they have to commit to including them. And only after that kind of being fixed and being finalized and the inclusion being confirmed, only after this will it be decrypted. So that's the one sort of use case area and target group. So we work with, for example, Gnosis chain, and we work with on Optimism, and we have an Optimism grant to work with those chains essentially on the protocol level, and then we also have just a larger sort of array of use cases. One of them being, for example, a voting. So then we work with Snapshot, and Shutter is integrated into Snapshot as a shielded voting mechanism. So it encrypts the real-time results during the ongoing vote. And then again, just like in the MEV sort of mechanism, it decrypts after the vote is over. Yeah.
Interesting. Maybe take us through what might help the listener is if you take us through the kind of the customer journey of and where Shutter fits in the stack. And so if let's say I'm a trader and I do some kind of action with I do a swap. Where in the customer journey would Shutter Network kind of fit in a transaction like a swap, for example?
Yeah, it's a complex question for us because it depends on how and where we integrate it. So ideally, actually, that customer, the trader, wouldn't even have to notice Shutter. They would ideally just be protected because, let's say, it is integrated into Gnosis chain, and they just benefit from its protection. That being said, we depending on how we integrate it. So one thing we're doing now is we collaborate with MEV blocker, and there for Ethereum L1. So if we want to offer it for Ethereum L1, then we would potentially, as a first step, collaborate with MEV blocker. And then the trader would use, if they already are used to using MEV blocker, they would see in their configuration options, they would see this even more private transaction route essentially. So if you're familiar with Flashbots Protect, they have different sort of options where you can configure kind of different privacy levels. So this could be another way where the trader interacts with Shutter, where they could see within MEV blocker, okay, this is the traditional private RPC, and this other option would be have this higher level of kind of decentralized, actual mempool encryption, not just it sort of being private because you trust the private RPC, but you have this sort of added decentralized level of lower trust, less trust assumption, more decentralization essentially.
So I want to maybe explore a few things that you said. So you said that one of the target customers are chains, and so these would be kind of roll-ups, layer twos, and it sounds like that Shutter Network supports Optimism chains built on the OP stack. It sounds like, as well as applications. Is that correct?
Yeah. So those are kind of two different products we have. The one is sort of the encrypted mempool on the protocol level, and the other one we are now calling Shutter API. Actually, not released yet, so we'll little tease. So we call that Shutter API, and that'll be this more application layer focused product where you can just call the API to request encryption or decryption.
And maybe we can address the first target audience. So the chains that integrate Shutter Network. What is that? I guess how does the integration look like? Let's say I'm a layer 2 blockchain, a roll up, and I want some level of MEV protection and privacy for my users. How does that integration work with Shutter Network?
Yeah. So for example, on the OP stack, we are partnered with kind of most of the rollup as a service providers.
Okay.
So for example, Conduit and some of
All
these
layer.
others.
Yeah.
Yeah. And so presumably you are with one of these. And for example, in Conduit, you'll see the Shutter integration being offered on their website. And so if they would like to again, offer this kind of encrypted mempool for their OP stack chain, that's a way to get in touch with us. And then what we have is we have an OP stack fork essentially, or we have our own OP geth version that the sequencer would run essentially, and that would plug into, or that would connect to our keeper set and this encryption decryption mechanism. So it doesn't mean the transactions are going to be sent to us or the Shutter network. It would just mean they would receive keys from the Shutter network. So they run the specialized OP-geth version, and what would happen is users send encrypted transactions to their sequencer, and the entire sort of key management is being done by our decentralized network of keepers.
And that would be like a reveal key. Is that right?
Yeah. So the user actually can derive the encryption key locally from an older kind of master key. So that actually doesn't need any interaction between these nodes. But then afterwards, to decrypt and to reveal, that requires the kind of the threshold of nodes to collaborate and to generate the decryption key, and then that gets broadcasted, and then the sequencer in this case would pick up the decryption key and decrypt. But the important thing at that point, it is available to everyone, so everyone can see, and ideally everyone can see at the same time the transaction contents. Yeah.
Now the field that you're describing is sometimes known as differential privacy. And I wonder, I haven't seen that phrase used on the Shutter Network website or in its marketing materials. And I'm curious, do you see it differently? Do you see differential privacy as something different than what Shutter Network does?
Interesting. I'm familiar with differential privacy from the perspective of you can add noise on sort of data, right? And then you subtract the noise afterwards. So yeah, and in that sense, it's a little different because we're not really even providing privacy, right? So it is really more so, yeah, commit reveal. So just temporary encryption using the threshold encryption, and then it'll be decrypted afterwards. So we're not even using that word privacy a lot because, I mean, some people would call it a mempool privacy, but yeah, it's a little bit misleading because it doesn't really provide anything in terms of anonymity or, yeah, traditional privacy.
I see. So what are the main distribution models for Shutter Network is Shutter Network as a service is provided as an option in these roll-up as a service providers like AltLayer and Conduit and Gelato and others. So if I spin up a layer 2 blockchain, a rollup using, let's say, AltLayer, and then I choose Shutter Network as one of the services that I want, what is that? Is it a very hands-on integration, or is that something that can be done kind of self-service? What does that look like?
Yeah, unfortunately, not yet self-service. So you would need to, yeah, work with us a little bit. So again, we have an OP stack test net. So for OP stack, it would be relatively straightforward. Yeah, but you just need to switch out your OP-geth binary. But yeah, depending on whether you have done some other modifications to your OP-geth, that might require some, integration. So I would say somewhat hands-on, definitely. Yeah. So yeah.
Let's go to the. I want to read something from the Shutter Network X account. The pinned account says something very provocative that I want to explore with you. It says, and this is a tweet from February 11. It says, Ethereum's transaction supply chain is broken. Maybe we can explore that a little bit, because I think that points to the problem that Shutter Network is a solution for. So maybe explain to us, what does that mean, that the Ethereum supply chain is broken, the transaction supply chain?
Yeah. So yeah, today's transaction supply chain is really kind of a result of there originally being a lot of front running and kind of in the public. And there was this public mempool, right, before this PBS transaction supply chain, and that was just pure mayhem, right? Kind of the transaction, you send a transaction out in the public mempool, everyone can see it, and you just have this race of people trying to front run and extracting MEV, front running or back running or whatever. So we had flashbots coming in and sort of building, and now we have, and this culminated in this PBS transaction supply chain, out of protocol PBS, proposer builder separation, meaning essentially a more organized market system around selling kind of these MEV, the MEV opportunity, right? So I think that's important to know as a background, right? So that's how it grew, which is better than probably a lot better than this full sort of chaos state. But it also brought with it sort of really a chain of, again, this transaction supply chain of transaction supply chain intermediaries that your transaction has to pass through until it's even kind of on the chain, right? So you have to send it through the RPC. It'll pass through the hands of kind of MEV searchers, relays, builders, proposers in the end, right? There's the transaction supply chain. And unfortunately, kind of in each of these steps, there is sort of centralization vectors, and there is the opportunity to censor. And usually you just have to trust each of them kind of not to censor and not to front run. So that's what we mean when we say the transaction supply chain is broken. It's because we sort of quick fix some of the front running or some of the chaos, but we introduced a really long chain of centralized intermediaries that each of them comes with trust assumptions, and that each of them can actually censor. And now, especially on the builder side, we only have two builders, right? Beaver build and Titan, who build sort of close to 90% of all the blocks. Um, and and then there's a dashboard. Tony Waschter from the Ethereum Foundation has a really nice dashboard where you can see each of the transaction supply chain intermediaries and how much they censor, right? And it varies a little. I think it's been better right now since compared to like a couple of years ago. But even the possibility of kind of very small amount of actors being able to censor your transactions, that I think is not optimal, right? That's not how we wanted to have Ethereum. And how sort of the entire idea of public blockchains is sort of to provide censorship resistance, right? And if we build this complicated transaction supply chain where each of the actors can censor and front run, that's really not optimal, right? And that's what we mean by it being broken. With it comes this builder centralization problem and vector. So yeah, and we think there is a set of solutions, right? And the encrypted mempool, I think, is what we think is one of them, right? Yeah.
Of the chains that have integrated Shutter Network into its stack, what has their feedback been so far?
So it's special because the one that we are live, Gnosis chain, is sort of what was a key part also in helping, and also kind of had the same sort of thought process that we had, Martin. So their feedback is positive, right? Because they want to see that. And then is in general positive, but then we do have some. It's not easy, right? It is a decentralized validator set that plugs into a decentralized threshold encryption keeper set, and there is kind of peer-to-peer communication complexity there that we're still in the final stages of ironing out. I would say that's kind of some of the downsides or the negative feedback that's not 100% working perfectly yet. I would say, yeah.
Yeah, I see Shutter Network almost like a there's kind of a set of services like an RPC, for example, where when the RPC is working great, the users don't say anything, but when it's not working, everyone's mad and everyone says, they're upset at the at the foundation that manages the chain. And so I wonder if Shutter Network is kind of a similar service where if my transactions are MEV protected and everything just works smoothly, and then your users don't say anything. But when people get sandwiched and they lose money, then they're really mad. Is that kind of a correct characterization, you think?
Yes. Yeah, I think it's just fair in general. I would say that from the chain's perspective, you could also look at it more kind of as a positive feature set, right? You have mempool encryption now, and you have sort of detrusted your sequencer. You've taken an alternative sequencer decentralization path in this, right? Because we need to think of why are people decentralizing sequencer? It should be kind of about censorship resistance. So kind of like this mempool encryption could offer an alternative to this, because it also provides censorship resistance. And then, but yeah, sort of in general, yeah, it is kind of like a security feature in a way that yeah. So censorship resistance, front end resistance. Usually, you would ideally as a user, you don't care about that until you only care about it in the negative if you get front run, right?
Yeah.
Or if you get censored.
And services like that are always hard. I mean, because they're so valuable to the user, but they only really pay attention when it's not working.
Yeah.
And so marketing a product like that is hard, especially with, to the end user. And when it's not working, they typically don't know that it's Shutter Network, and they instead blame the chain. And so how do you deal with situations like that where your primary customer, your primary user is the chain in which you integrate. But then there's also end users who benefit or not benefit from the effectiveness of Shutter Network. I guess, how do you deal with in those situations?
Yeah, I think you nailed exactly sort of our marketing challenge, right? Is like, yeah, the beneficiary isn't necessarily the same as the one we're selling to. Yeah, and I guess there's a number of answers right now. Yeah, so I would say is one is on the marketing side is education, right? First, we're trying to help people just even understand this problem and trying to break it down. Have started to do a lot more video content and to do a lot more infographic content, which tries to break down the problem in more simpler terms. Um, uh, um, Another aspect of it is we need to I think we need to actually just get closer to the user as well on our side, sort of more vertically integrate in a way, which some of it we are doing via these partnerships, I would say, and then just working very closely with, again, someone like MEV Blocker, who is still like a little bit of a back end product, right? Because they're an RPC, but they're one big step closer to the user, and the user makes the decision to switch to MEV Blocker. So that's another step we've been taking, especially on this roadmap towards trying to bring that to Ethereum L1. And then one smaller thing, or something very recently, I think I've been just experimenting with building sort of wallets, or just building that ideal version of, because there's also like a big change happening in kind of UX, right, and to agentic user experience, and not having a wallet or a dApp or a DEX aggregator, but having sort of a broker agent, right? And I think one thing we'll show as a little just as a showcase, essentially, will be this little agentic user experience, which is still fully local and would still have this transaction encryption component in it. So it's kind of like the antithesis to the broker agent, where you give the broker agent your trading intent and then they can front run you. This one would be the agent that you own yourself, right? And that kind of lives inside your own node, or lives inside your wallet, essentially. Then still sort of being able to offer the same UX, but having it with local and having it with encryption in mind, so that it is working for you and not against you, essentially. Yeah, I think it's, and we probably won't really build a wallet, but just building that little mini sort of app, I think is sort of, again, an educational tool, showing people why this matters, right? Especially in this age of kind of the agentic broker age, where I don't know if you've seen this stuff, like, for example, the banker agent on Twitter, on Base, where literally people tweet at it, right, at BankerBot, send 5,000 dickbutt tokens to this other person, and it buys it for you and then sends it. That's amazing, right? And it's really fun. I use it. I love it, right? But the issue that it really surfaces this issue of giving out your trading intent to in this case, even fully public, right? That makes it very obvious that anyone can even see the tweet and take 3 minutes. They have 3 minutes of time to front run you, right? But even if it's private, even if the agent's private, it's still not optimal, because they then have this trading intent and they can front run you. So I think that's one way we're trying to address it, by making it more obvious, building little apps building apps as a marketing tool. Now with ChatGPT, it's very easy to build these apps, especially in this kind of hackathon 80% way. And then the other big thing we've been doing is we've been also kind of splitting our attention into this a lot more simple product, this Shutter API, which is not really dealing with sort of protocol level transaction supply chain complexity, but it is on the dApp level, and it offers just, again, encryption for dApps or even Web2 apps. So snapshot shooter voting, but we also see things like gaming, where you have simultaneous move games, that where you need sort of that level of privacy. Rock paper scissors would be a small example that could benefit from this. And then and they're also building small apps to showcase how people would use this. It's one thing we're trying to how we address this challenge.
You mentioned gaming. I'm thinking of I've never really seen kind of poker fully on chain because obviously you could have people front running you and finding out what your cards are. Would a service like Shutter Network help enable fully on chain poker?
Very interesting question, and I've built a little poker using Shutter. But I think Shutter in today's form doesn't solve the entire problem. So I think Shutter would cover sort of part of it. So, or depending on how you think about the card shuffling. So to simplify, I think you could use Shutter to hide the card shuffling and then randomize and then give people kind of cards that they don't see nobody sees until they're revealed, right? But that would be fully random. Whereas in real poker, you need to draw from a deck and you need to be sure that the card that one player has isn't the same as the other one, right? And that step, so if you want to do it properly, that would require sort of computation over encrypted data. And that's not something that this more simple today's iteration of Shutter with just threshold encryption can solve. But we're looking into kind of extending it. We're looking in. I think you had a million on your podcast. So that would be one direction we could take or work with them. We're friends with them or some of their team. We could develop Shutter in that direction, more sort of more fully fledged MPC, and or in this other kind of FHE direction, where Shutter would still provide kind of threshold key generation essentially, but then not for encryption decryption, but for this FHE circuit. So you could call it threshold FHE, and then I could do things like this in poker. I think it can still add a tiny bit of value, and I think we'll publish a little mini, again, just a mini sort of POC of this poker. But also from the perspective of enforced reveal of the cards. So I think that's one. It's not the core problem I think that you described, but a separate problem in poker could be that that there are cases where you need to force a player to reveal their cards, or you need to force the game to reveal cards or the player to reveal cards, and that is kind of a Shutter feature, right? You could forcibly decrypt. So probably not really solving the core full kind of encryption on over encrypted data, but like a subset of that.
No, that's very interesting. That when you mentioned gaming, then I started thinking about what types of games would really benefit from something like the encryption.
A simple example is diplomacy. If you're familiar with diplomacy.
I'm not. No, tell us.
So it's a little bit like Risk, but more about diplomacy. So you less about attacking, more about. I think it's a very nerdy game where people have to sit for days, kind of, and have to negotiate and kind of take over countries, but not more by diplomacy rather than attacking. You can also attack, but it's more about this really game theoretical collaboration or not collaboration and alliances and whatever. So my colleague Yannick built a version of diplomacy called Diplomacy. So DAOs playing against each other. And in diplomacy, all the players need to move at the same time. So it's kind of one, they all move, and then the next phase begins. And if you do that, again, on chain, as you said before, with poker, you would see everyone's moves as they do their move, right? And then people would be able to see, I already see their move. Let me restructure my strategy and my tactics. So that is a typical. That's a typical use case for Shutter, and that's where we built a little prototype in the past. Simultaneous move games. So you would encrypt the DAO moves, and then until the round is over, and then only when everyone has moved, only then would you decrypt and reveal everyone's DAO moves.
I see. Oh, what about a game like so there's a class of games called social deception where um uh, I think it's called Murder in the Dark, where I'm the murderer, but no one else knows I'm the murderer. But I'm trying to bluff and tell people I'm not the murderer so that they'll pick someone else to become the murderer. Um and so like social deception games like that would Shutter Network would it make sense to have like an on-chain version of Murder in the Dark with Shutter Network kind of powering underneath?
Yeah, I'm pretty sure actually that. So I think another version of this is Werewolf, right?
I think so. Yeah,
Yeah, and that's something we've discussed in the past, and I think that would be a perfect fit, for similar reasons as we discussed before. Yeah.
that's great. Let's switch topics to Shutter Network branding. If we go to the homepage, I find that reading the headline and subheadline kind of gives us viewers a sense of who you view as the target audience for Shutter Network. And I just want to read the headline really quick. So headline says fairness isn't optional, and then the subheadline says keeping crypto true to its roots. Shutter empowers dApps, DAOs, and chains with the highest standard of privacy and fairness. What do you think of the headline and subheadline? And do you feel that that speaks to the target audience?
I would hope so. Again, I'm not I'm not a marketing expert, and I'm not, especially not really an expert in breaking things down for uh, breaking things down easily, to be honest. Uh, but so so yeah, I personally feel relatively strongly about this sort of back to the roots,
Yeah.
cypherpunk ethos a little bit. Yeah, and so one thing, yeah, and then one thing I would always question internally is if fairness is that the best um it is fairness and privacy is something that people, how much do they care about it? Uh, on some level, obviously, right? It's always something that um yeah, if you ask someone, do you care about fairness and privacy, you would say sure, yeah. But then if you ask them, do you pay for it? They would probably say at some point no. So I think at some point, or depending on who we target, I think sometimes we need to tell a different story and we need to talk more about. So another way to think about fairness is accessibility and its kind of mainstream appeal. So so one thing I would prefer is maybe saying something like leveling the playing field, uh, not for sort of fairness sake. Obviously, yes. I mean, obviously, it should be fair as well, but um, not just about that, not just about fairness, but also if you level the playing field, you can have a lot more people play, right? You won't just have this elitist game of people who know exactly how to use sophisticated MEV tools or protect themselves, whatever. But if you kind of in general level the playing field, you can hopefully increase the pie and get more people to play, right? And then you increase the value of the amount of transactions, and you get more, you just get uh, more trading volume. You might even get more MEV. So what we're saying is we can only prevent front running MEV. We can't even prevent back running MEV. So in this sense, we could even make the argument that then we can increase the amount of back running MEV. We could even increase the MEV searchers revenue
Mm-hmm.
in the chain if they can make it an enjoyable and kind of safe trading experience. Yeah, so I think that's maybe something I would prefer kind of in our messaging to change in this way, that we're fairness is good, but I think even better is connecting it in some way to leveling the playing field, and then from there to sort of accessibility, and from there to hopefully getting more users essentially. Yeah.
Yeah, I think that makes sense. And maybe we can back up a little bit. You know, we've been using the acronym MEV. Maybe help the listener understand what MEV is and why it's bad, and how Shutter Network can help prevent, reduce the instances of MEV.
True. Yeah, sorry, we jumped over that a little bit there. MEV is maximal extractable value. And it is the amount of value that can theoretically be extracted by censoring or by front running or by reordering transactions, and usually ultimately by the entity that has this ordering capability. So in the classic Ethereum sense, it is the validator who receives transactions from the public mempool, and they can choose the final order within the block. Yeah, and by front running, for example, seeing a big order coming in that is a buy order, for example, for an asset, that would definitely move the price a little bit. That's a classic front run opportunities where you can see, okay, if I slot in here because I can order the transactions within at least within this block, I can slot my order in, buy cheaply from the market, and then sell to this poor guy who already had committed to his transaction. That's the classic front running. So it's bad because people lose money this way. They get worse prices because they get front run. They get failed transactions because it exceeds the slippage. So then they get failed transactions. And maybe one level higher, essentially is I would say is we solved this transaction ordering problem for a long time scale. That's kind of the whole innovation of Bitcoin essentially. If you read the Bitcoin white paper, Satoshi talks a lot about the clock. Kind of, you need a clock to order transactions in a way. So on this 10-minute level on Bitcoin or 10-second level on Ethereum, we solved that transaction ordering problem, but essentially we didn't solve it for sort of timescales below 10 seconds. And that's kind of where the MEV happens. And MEV is just, it's again the value that can be extracted. And then one thing I would say is it is extremely broadly defined in crypto. So in the real world, you wouldn't mix. So in the real world, you also have front running. It is actually illegal, right? But in the real world, you have arbitrage and you have high frequency trading. And in crypto, it's all one thing: front running, arbitrage, liquidations, all are MEV. So that is sometimes a little bit confusing because arbitrage is, I personally believe arbitrage is good, right? We need arbitrage to equalize prices between exchanges, and we need obviously liquidations, otherwise, MakerDAO doesn't work. So that makes it sometimes a little bit confusing. Saying, is it good or bad? No, arbitrage is not bad. Arbitrage is sort of extremely needed. But front running is bad. I would say it's kind of relatively clearly front running is bad. And again, that's why it's illegal in the real world, actually. And then also, I think also in general, also bad is sort of selling order flow. I mean, that's where the debate, I think, starts to get a lot more nuanced and interesting. I think selling order flow is also sort of bad. And again, pointing to the real world is something that is actually banned in the EU. It's called payment for order flow, PFOF, is banned in the EU. For example, Germany still needs to enact it, so it's still legal this year. But then at the end of the year, they have to also ban it, and that will hit a lot of these kind of cheaper brokers very hard because they relied on Robinhood, I think in the US does this as well. They rely on selling the order flow of their retail order flow to market makers for the cheap trading fees, right? That's the whole value proposition. But yeah, and that's where you can argue more. Like, this is some way good for the users because they get lower fees, but in the long run, it's probably not really good because the prices are affected, and you are again selling people's. You're benefiting from this insider information of the users' trades, and people and these market makers make a lot of money, and well, it is a zero-sum game. Somewhere someone needs to lose money for it to work.
Yeah.
And we can't really say that it is positive. Some people would argue, well, it is information that you're putting into the market, and that's what you're getting paid for. But on these timescales, like sub 100 millisecond timescales, not sure how much really valuable information are you adding to the market that you should get paid for.
Yeah. As you described that, I immediately thought of Robinhood because I think their entire business is payment for order flow. And so, and I don't know this, but apparently they're probably not available in Germany then, right? Because of the laws there.
I think they just have competitors here. So one in Germany is called Trade Republic. They have the same, yeah. And again, it's still legal this year, so they could have also entered the market yeah. But I think going from next year, it'll be a lot harder for those type of brokers they really have to rethink the business model.
Yeah. So now going back to Shutter Network and how it helps reduce the problem of MEV, tell us how it exactly does that.
Yeah. On a higher level, very simple. On a higher level, you just say you encrypt your transaction, and this party that we just talked about, right, is in the real world, it's the exchange. In crypto, it is the validator, or it's a sequencer, or depending on who kind of how you're trading, but it is some transaction ordering authority. But they have to commit to the order and to the inclusion of transactions while they're still encrypted. So they kind of receive a sealed envelope, and they have to sort of stamp it, and that's where your trade is inside the envelope, right? And then they pass it on, and only after this does it get decrypted. So that on a very high level, and then the complexity is around making that encryption decryption be decentralized, right? So trivially, the user could just encrypt with his own key, but then they could choose not to decrypt later. So if the user would encrypt and then decrypt at the end, you would have kind of what's called a free option. So you would then, if the price or something goes against you in those couple of in that time, you would then choose not to decrypt, and that would break the system again. Kind of, you would then have like half of the trades would then always sort of fail, presumably because people would just choose not to decrypt. That's why we need kind of a secure way to decrypt and to enforce decryption, I would say. Yeah. And that's why we have this threshold encryption mechanism and this keeper set.
I think the visual of the sealed envelope, you mentioned earlier about, educating the market on the MEV problem and also Shutter Network as a solution. I think using the sealed envelope visual, I think is a very good, because it's relatable to understand what that is. And I think could really help to explain the value proposition of Shutter Network.
I like it as well. And I like this, you can have both, right? You can close the envelope, you can put your intent in there, and you also have to stamp it, right? And that's what the validator does. He kind of validates and stamps transactions.
Yeah, that certainly helped me, and I think could help a lot of people. It makes it relatable, and I think a lot of things in blockchain and crypto is it's complicated. It's highly technical, and we need more simple educational materials that will help them understand the value of the service and the protocol, the chain, the application, and what it means for them. And I think simple stories like you just shared about the sealed envelope with the stamp, that kind of story, I think is really helpful.
Agreed, yeah.
Okay. Well, Luis Bezenberger, thank you so much for sharing your time with us and telling us about Shutter Network. I will share in the show notes all the URLs that so that people can become more familiar with Shutter Network.
Thank you so much. This has been a really, really nice talk. As you said, really casual, and I think you brought out all those topics that are sort of important to us, and identified our challenges as well. And I think yeah, really thank you for that.
Thank you.
Awesome. Have a good day. Rest of the day. Bye.